Kind of like Mr. Bean. Have you ever seen Mr. Bean? Like when you watch it, did you just go, this is so stupid? But then by the time you're done, you're like, he's hilarious. And you figure out this is so funny. Okay, that's kind of like the Red Green Show. All right. Here we go. Everything we're going to do today, we did yesterday. We're just going to put this into a real life example. Okay. So remember the car that we purchased for $20,000? Remember that? And they told us what happened here. They said, here's the formula for it. It's going to lose $1,250 every year. What kind of relationship, what kind of a line was it when we drew it?
Down.
It was a down line, yes. Was it a curve or was it a straight line? Straight line. What do we call those? Linear equations. If it's a straight line, it's linear, okay? Those U shapes that we've just seen, we just worked on one, that's non-linear, people, okay? That's not linear. Linear is a straight line. Got it? Okay. It says we're supposed to do that using a graphing calculator. So grab your calculator. Let's graph it. Let's put in there y equals, clear what I got. I'm going to put in 20,000. Make sure you have 20,000 and not 2,000, please. Put the right number of zeros in. Minus 1250. Oops. Oh, for heaven's sake. Right? 20,000 minus 1250x. And we go hit graph. And nothing shows up. Mrs. Sewell, it's not working. I'm like, oh, heavens to Betsy. Okay, so what do we do when it's not working? What is the problem? The windows. So go to your windows. Let's talk about this. Talk to me about what's happening along the x-axis. You have to know the scenario. Consider the context. What is on the x-axis in this equation? Time. So can time ever be negative? No. So we're going to start with our minimum being 0. Let's consider the context. Okay. If you remember what we did before, do you remember this question and when it became worth nothing? Remember what the number was? Do you remember?
16.
Like 16 or something? So we need to go beyond that. Let's go to 20. Let's go to 20 for our maximum. Scale of 1 is fine. Okay, let's go to the y values. What is up and down on the vertical axis? What is it? Cost, value, yeah, money. So do we need negative values? Not really. It's not bad to leave a little bit there so that the axis goes down a tiny bit. Let's leave the negative 20 there, understanding that we don't really need it. But what does the maximum need to be? At least 20,000. So let's go 25,000. 25, 1, 2, 3. Now you do not want to leave your scale at 1. That means your calculator has to make 25,000 marks on it. Little ting, 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 ting. So can we go by 1,000 instead of, let's try by 1,000. So down to your scale and make your scale be 1,000. That will still be a lot, but at least it'll be better than 25,000 little marks. Okay, let's hit graph and see what happens. Hey, pretty good. Looks pretty good. Okay. So we've graphed it. So you're supposed to draw that on your page. So go ahead and draw it on your page. Something like this. Oh, I must be nervous. Okay. Okay, now. Oh, this says use ZoomFit. We don't use ZoomFit. We use our heads. Okay, use your brains. ZoomFit is on there. You can look on your calculator and ZoomFit, but it will give you the craziest funky answers and numbers you've ever seen. I really encourage you not to use ZoomFit. Okay, you can try it someday on your own time, but it does not work. Okay, I'm just gonna clear this. I'm gonna draw a good line because I was nervous. I'm like, what's he doing? Okay. Okay. Oh, hello. Now it says, going down, sketch the graph. Okay, I did. Good. Part B. Calculate the t-intercept. Okay, now wait. Where is t? Oh, so label this. This is T, and this one up here was V for value, right? So know that, first of all. Label your grid, label your axis. I'm going to tell you to do that. You have to label it, okay? And then it says find the t-intercept. That's like the what? In other words, find the what? The x-intercept, right? X and t are together at this point in this question. They're both horizontal. Are you with me, Victor? Okay, so when it says find the x-intercept, what am I going to do? No. Y equals 0. That's what I'm thinking about because this is the same as my x, right? So y equals 0. So you grab your calculator. Where do you put the y equals 0 stuff? In your y equals. In your y equals. Go to your y equals, put 0 in there. Hit graph. It'll be a red line or a line across the bottom. You may or may not see it. Make sure you put y equals 0 in there. And then we go second function, calculate, an intersection, enter, enter, enter. And we get that it's 16. We already knew that. This just confirms it, okay? So the t-intercept, t equals 16. Now it says label it on the sketch. Okay, this is 16. This would be the point 16 and 0, correct? And then it says label, okay, find it, label it. So far, so good. The next thing says describe what this value represents in the context of the question. What does it represent? You need a sentence.
The years.
The years for what?
Until the car has no value.
Until the car has no value. Make sure you tell me what does the 16 and what does the 0 mean, right? So the 16 years until the car has no value. Understand? Next question. Calculate the v-intercept. Okay, v, what's another word for v in this case? Y. So I want to know the y-intercept. What do? X is 0. So make yourself a little note. I'm going to go with x is 0. So on my calculator, how do you say x is 0? Do you remember? Just do what? For where? In the y equals?
No.
How do I put it in the x? I'm going to get rid of the y equals. Oh, you just put trace. So you hit trace and then 0. When you hit trace 0, you get 20,000. Surprise, surprise. Right? And what does that represent in the context of this question? The value of the car when?
That is max. When it's at its highest.
Yeah, but when, tell me about the T. When it's brand new, when there's been no time. Okay, so this is value of the car. Make sure you talk to me about value and time. So when it's new, not just any old time. When it's brand new. Okay. Then it says, use the trace feature of a graphing calculator to determine the value of the car, what it'll be worth in 5 years. In 5 years, is that the V or the T? T. How do you say T is 5? Trace. Trace 5. Trace 5. That's the X. Hit enter. 13,750. 13,000. I have no screen. Any suggestions? My screen is black. Hold on. I'm over here. That's so weird. It just totally went black. Control Shift what? I don't trust you all in your control. Okay. $13,750. You got it? Okay. You do this. Do the next part on your own, and I'll try to figure this out. It says use the intersecting feature of a graphing calculator to determine when the car will be worth half of the purchase price. What would that be? Y would be the Y value. The V value would be 10,000. Go do it. Finish this all out. Oh, what happened to my thing? Oh, there. Oh, we're back. Just the brightness. We're all good. Okay. Huh? Is that what you said? It was just brightness. Yeah. So I touched something, obviously, with my button. Okay, so we're doing that. Go find it quick. How do you do this? Y equals 10,000 on your second line. Right? Do it. Tell me what you get. We have somebody says 8 years. Somebody else agrees. 8 years. So 8 years. Illustrate this on your sketch. Illustrate means draw on your sketch right here. This would be 8 years, $10,000 worth.
Do you have to draw the line?
Sure. Sure. Yes, Kale.
Can you show us how to get that? Sorry, I was like the lines like above.
Did you put in here y equals 10,000?
20,000.
Yeah, 10,000. Half the value, right? Okay, and the last but not least, write an appropriate domain and range. Okay. This is where the rubber meets the road. Here's what I need to know. So, given my picture, what do you suppose the domain needs to be in the context of this question? Tell me the numbers. 0 to 16. Okay, so here we go. The domain, I'm going to put D for domain. What letter do I need to use for domain? T. Such that we're going, since I have two values, I'm going to put 0 on one side, 16 on the other. What goes in the middle? T. Write the T in the middle. Then I use these lines. My next thing is what kind of numbers am I going to allow T to be? Is time continuous? Yes, it would be a solid line, right? Time doesn't jump. We don't time travel. So T is an element of real numbers. All the real numbers, all the decimals and fractions, all the little tiny pieces, time is continuous. Okay. Talk about the range. So we're certainly talking about a V. Good. What's the appropriate window for the context of this question? 0 to 20,000, right? So I put my 0 on one side, I put my 20,000, I leave a space in the middle. What goes in the middle? V. Here goes my signs, right? Then, is the value continuous? Yeah. Good. Hey, these little squiggles by the line, they're not really squiggles. They're actually a brace. It's like pretty. When you were little, did you do your birds like that? Anyway, just a little V or a little, I did mine like an M actually. This was my bird in the page. That was my bird. Yeah. Okay. All right, next question. Same kind of context. There's a real life question. I don't even think I need to do this. Do I need to do this? Yes, I do. Yes, I do. I just remember there's a feature I haven't yet showed you in your graphing calculator. Okay, the height of a human cannonball, cano. Okay, you could be the human cannonball. Can be described by the formula h equals 12 plus 16 minus t squared, where h is the height in meters above the ground level and t is the time in seconds. Cano is projected out of a cannon, this would be fun, from the top of a building and lands on a big old soft mat. Wouldn't that be so fun? Oh, have you ever been on the water slides in West Edmonton Mall and it starts counting down and you know you're about to fall?
Oh, the one that
Oh,
moves?
man. Oh, it's so cool. Right? Your heart is just rushing as it counts down. Isn't it so fun? So you can imagine that you're in this thing that's about to shoot you out. Oh. Yeah, the floor drops. Okay. Yeah, it doesn't really feel good. Just saying, it's not really comfortable. Okay. Okay, come back to me. I gave you your 30 seconds. All right. The mat is placed in a hole in the ground so that the top of the mat is level with the ground. Okay, so we don't have to account for how high above the ground is the mat. We don't have to go there. We're just hitting the ground, okay? But the ground is a mat. So it says display it on the graph and calculator. Okay, let's go. Is this going to be linear? Anybody? Anybody think it's going to be a linear equation? No. How do you know by looking at the equation? There's a little squared. Okay, good. I'm glad you caught on to that. So I'm going to go 12 plus 6x minus, yeah, everybody needs to do this, x squared. Now, we got some funky windows going on here, folks, right? We went from 20,000. So can we just hit zoom 6 and just work with me? Put it in there, hit zoom 6 and graph it. Okay, so you kind of see the beginning of this. 20,000 was going to be crazy. You weren't going to see anything on your graph because we don't even go close to 20,000 feet high or whatever we were talking about. All right. So do you have a picture that kind of looks like mine? Yes, Danielle says yes. Okay, go to Windows. Let's talk about the context of the question. This is kind of like domain and range. Okay, so I don't have enough. We're going to change it. So on the x values, what is x-axis on this scenario? No. Time.
Oh, 20, right?
Time, right? T is time. We're talking about the height relative to time. The H and the T in our formula are height and time. So let's go. We don't need negative. Let's go from 0 to 20. 20 seconds to hit the ground. I don't even think we need that. I think 10 was fine. Let's leave it as 10, actually. It doesn't take you 20 seconds to hit the ground. That'd be a long flight. Okay, let's talk about our y values. What is the y in the up and down part in this equation? What was the h? The height. We don't really need to have the negative. Maybe I'll just go -2 just so that we could see the axis better. But the height, we need to do a little bit more. Let's go that one to 20. Okay, so make your windows like mine. 0 to 10 and -2 to 20 on the y's. Okay, let's hit graph and see what happens. Oh, we still need more than 20. Okay, back to your windows. Change the maximum on your y value to be 30. Okay, sure. I don't care. 25 or 30 doesn't matter. Hit graph. There. That's the part of our picture that we need. Understanding that the equation gives us a huge parabola, but we don't need it all for the context. Okay, sketch that. No. Okay, there's my sketch. Write down a window setting which would be appropriate. So how do we do our window settings? Remember? We go X, colon, and then we do a square bracket. Now, Kale? Yeah. I'll wait for you.
Where are your windows at?
My windows went from 0 on the X to 10. The min, the max, and the scale was 1. Correct? Joey? Yes? Let's talk about y values. I think on my y, I can go back and look. Did I go -2?
Yeah.
I think I went -2 just so that you can see the y-axis or the x-axis better. I went up to 25. You can go to 30. Whatever you put on yours is fine. And I left the scale as 1. Okay. So I put my windows down. You have to use square brackets to do that. Are you getting this down there, Miles? Yeah. I sketched it. Now it says, what is the height of the cannon above the ground? Not the cano, not the human being launching through the air. What is the height of the cannon? Where was the cannon at? I told you in the story. The height of the cannon is on top of a building. So that's why it's up high. So here's the point I need to find. Right there. What do you call this point? The y-intercept, which then means x is 0. So I need to say x is 0 here, right? So how do I do that on my calculator? Just go what? Trace, right? Hey, there's another way. Anybody, could you think of a different way to do that than trace 0? Second function table. Get your table. When x is 0, y is 12, right there. See it? You can use your table. Okay, don't forget you have one. So the answer is 12. 12 what? Meters. So either trace 0 or your table sometimes works, depending on what you're looking for. Okay, then it says, what is the maximum height that Cano reaches? I have not showed you this. The maximum height that he reaches is right here, correct? Look at, up here. That's maximum height. You can find it. Go second function on your calculator. Go to calculate. Don't choose intersection. We want to find the maximum. So go down to number 4, hit enter. Then it asks you some questions. It says left bound. It needs the left hand boundary. So move your cursor until your cursor is blinking on the left hand side of your peak. So ding, 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 move it over there. I think you can hold it and it moves. Hold it till it's on the left hand side of the peak, hit enter. Then move it to the right hand side of your peak. Just over the hill is fine. Hit enter. Then it will say guess. You can say, no, you guess for me. And it will guess. And it turns out to be 3.000021 and 21. What do you think the maximum height is? Oh, your x value is 2.9999999. Okay. What's that? And then what's your y value? 21. Which one do you think is the height? 21. The height is 21 meters. Now, why does yours say 2.99999 and mine says 3.0000112? Do you know why? Because your little pixel thing, the little way this calculator is actually made is little tiny squares, and it can't get exactly there. But when you get 2.99999, you know it's 3. Do you know how else to know it's 3? Go check your table. Look on your table and confirm that it's actually supposed to be a 3. It just can't get exactly to that spot. Yes?
Can't you just do that for the height too? You just go to your table and look for the biggest.
You could, but if it was a 2.5 and you don't have 2.5 on your x side, you wouldn't find it. So much better to use your calculate the maximum. Okay, so we learned something today. There's a maximum and you can find it. Same thing with actually minimum. Then it says, don't clear this yet on the table. How do you get out of the table? Okay, good. Okay, then it says don't clear this yet. It says how many seconds does it take Cano to reach the highest point? How long did it take to get there? We know it's at 21. How long did it take? 3 seconds, that's right. So that value right there is important. So don't clear your calculator unless you keep reading. 3 seconds. All right, then it says, to the nearest hundredth of a second, how long does it take for Cano to land on the mat? All right, so what am I looking for now? I'm looking for this little point here. He hits the mat. Everybody sees what I'm looking at?
Yep.
Joey, I'm over here. Looking over here. I want to find this little place. X-intercept means what?
Y is 0.
Y is 0. We know what to do. We go in our calculator. We put y equals 0. We find the intersection. You can graph that. Someone find me an answer.
7.58.
7.58. I'm going to the nearest hundredth of a second. You're right on. 7.58. Please write seconds after it. Okay? Getting there? So we did if you want to know what we did here, we calculated an intersection, right? If you want to make notes how we're doing what we're doing. And we said y equals 0, right? Okay, how high is Cano 1 second after he's launched? What are they giving you? What's 1 second? Time. Where is time? The x. So how would I find out how high he was after 1 second? What can you do? Trace 1. Now, I don't know what this is going to do because I'm going to go in here and get rid of my y equals 0 line. So then when I go trace 1, it tells me it's 17 meters high. Well, how else could you do that? On your table, right. When will Cano be at that height again? Uh-oh. When will he be 17 meters? What is 17 meters?
X5.
How did you know that? Were you on your table?
Yeah.
Okay, you could look at your table and see if you could get 17 again. So on your table, you could just scroll down here. You go, oh, there it is, right there. On your table is 517. Now that only works because 5 is an exact number. If it was 5.2 seconds, you wouldn't see that. So okay, we know it's 5 seconds. What else could we do if you couldn't use your table? Don't you know the height of this is 17? So wouldn't you want a line going across like that? So you found this point and you need that point. So yeah, you would say y equals 17. And you could find an intersection again. Right? Okay. Last question. It says, in words, describe the relationship connecting height and time. Describe in words, connect height and time. What happens? Tell me what's happening to Kano in relation to height and time. There's a lot of words. I could type. I think I can type on this thing. Can I type?
Yeah, text box.
Text box. I think I can start typing. Okay, what would you say? In relation to height and time, what would you say? Kano starts at a height of 17 meters, then increases until what? He reaches the maximum height of what? Of 21 meters. He then plummets to the ground. How do you spell plummets? Is that right? Plummets to the ground. And lands on the mat in a total of, I'm sorry, he starts at 12 meters, doesn't he? Okay, sorry. Starts at 12 meters. Increases until he reaches the maximum height of 21, then he plummets to the ground and lands on the mat in a total of, how many seconds was it when he hits the ground? 7.58 seconds. Okay, there. Little story about Kano, right? Just tell me what's going on about Kano. You don't have to write all that down. That's okay. Got it? Could you write that on your own if I asked you the same question?
No.
Oh, sure you could. Tell me what's happening. Just describe the picture. We're starting here. We go up, and then we come down. No big deal, right? Just describe the curve. You could write that in words. Okay, write it all down then. All right. We need to write an appropriate domain and range. Talk to me about the domain of my picture. What should it be? First of all, this was 7.58 seconds, right? Okay, so what does the domain need to be in this context of this question? 0 to 7.58, right. What letter am I using? T. 0, how do I do this? I write them down. There's 2 limits. What do I put in the middle?
T.
T. You must put T in the middle. Some of you aren't doing that yet. Hopefully you are right now. Time is continuous, so it's all real numbers. T is an element of real numbers. Okay, what about range? What's an appropriate range? Look at your picture. 0 to 21. Is that the height it gets to, the maximum height? Okay, so I'm going to put H for height. I'm going to go 0 all the way to 21. Now, if you just do what I do, you'll get this right every time. The little h goes in the middle, and your signs go that way. Height is also a continuous function. Good. Yeah? Do you know the one place kids make a mistake? They go 0 to 12. Why do they do 0 to 12? Because they go up this axis right here, and they go, 0 to 12. Well, no. That is not the maximum height. That is not the highest window you need, right? You need the highest window that you can get to, 0 to 21. If you put 12 on your window, you wouldn't be able to see the top. Don't put that. Think about the actual function. Okay, good. I'm done. Go.
Finish this.
We have the 2 lessons tomorrow and a quiz. No, work on your own quickly.